Hello and welcome to today's American Trainco web conference titled Boiler Safety, Operations, Practices, and Procedures. During the presentation, all lines will be in a listen-only mode. You may submit a question to our speaker at any time by clicking in the text box area at the bottom of your screen, type in your question, and then hit Send Question button below. Questions will be answered in the order they are received at the end of the presentation. Today's speaker is Tim McDaniel. Tim is the Technical Director of Mechanical Training for American Trainco. He has 29 years of experience in the boiler and HVAC industry and has served in various engineering functions and as QC Superintendent for ASME boiler manufacturing and repair. Tim has been a technical instructor for the past 13 years and is the author and co-author of numerous technical training books on boilers, HVAC and chillers, pumps and pump systems, as well as several other mechanical trades manuals. Thank you for your attention. I would now like to turn the conference over to your speaker, Mr. Tim McDaniel.
Good morning and welcome. It is a pleasure to have all of you here. We've got a great deal of information to cover in a short time, and I do look forward to your questions at the end. My information has already been presented to you, but this slide here just kind of goes over and gives you a synopsis of the information that was given to you previously. Also, to do my due diligence, I need to give you a little bit of information about our company, American Trainco. Some of you may be familiar with us, but for those of you who are not, we do facility maintenance training, building maintenance, and industrial maintenance. We offer live public seminars as well as in-house courses to meet your needs. And in our training, we do everything from basic maintenance training for the introductory people and the novices coming into the business, as well as training for those who have been there and are needing refreshers or new updated information for your facilities. So we look forward to being your source for training in the future. Again, I do want to tell you welcome. I am very passionate about the subject of boilers. In my opinion, oftentimes a boiler, as long as it is operating and it's not making any strange sounds or nothing strange is happening, it's one of those objects that is forgotten about a great deal of the time. However, most, I think, will agree that in most facilities, whether it be for heating of a building or for your processes, the boilers are critical for what you do, for taking care of people or producing your products. And, you know, even though they are so important, they are often forgotten. Now, in order for us to cover this information, the first thing I want to do is a little housekeeping here and just get some boiler basic information out of the way. So as we're using certain terminology, everybody knows what we're talking about. So first off, we need to understand that boilers are classified by their design. And in reality, even though there are many manufacturers out there that are manufacturing boilers, in reality there are only two types of boilers that are manufactured in the United States, that we use here in the United States. One of them being a fire tube boiler, the other being a water tube boiler. Now, what determines what they are is the relationship of the water to the fire for heat transfer. Now, in a fire tube boiler, the fire is on the inside of the tubes and the water surrounds the outside of the tubes. In a water tube boiler design, the water is on the inside of the tubes and the fire and gases of combustion surround the outside of the tubes. Whenever we think, there's a third type of boiler listed on this slide here that's called a sectional boiler. A lot of you may be familiar with them, cast iron sectionals. Even though we have it listed here as a third type, by its design of where the water to the fire relationship is, it would fall under what would be considered a water tube boiler design. However, in the cast iron sectionals, there are no tubes. There are metal sections. The water is located on the inside of the sections, and the fire and the gases combustion go on the outside for the heat transfer. So those are the types of boilers we deal with, but primarily keep in mind fire tube boilers and water tube boilers. Now, whenever we look additionally at boiler classification, we can look at how these boilers are used. We have two basic types of uses for boilers out here in industry or in commercial applications. One of them is for heating. Now, heating boilers will provide steam or hot water for building heat or comfort heat. The other type is process boilers, and often these process boilers are referred to as power boilers or industrial boilers. Now, these particular boilers provide steam or high-temperature hot water for uses in manufacturing, power generation, and other applications. Now, one term here, whenever I mention higher pressures or high temperatures, other ways that we'd say classify boilers also potentially for use is either as a low pressure boiler or a high pressure boiler. Now, by ASME definition, a low pressure boiler, steam boiler, has a maximum allowable working pressure of 15 psi, and from a hot water application, it's at 160 psi operating pressure or a temperature below 250 degrees Fahrenheit. High-pressure boilers have a maximum allowable working pressure above 15 psi steam, or a operating pressure above 160, or a operating temperature above 250 degrees. So we have the design that we can classify a boiler, or we have the use of that boiler in ways that we can also classify it. Now, when we start talking about boilers, there's a lot of things that come into play for a boiler. First off, we're going to take a real quick look here at what systems are required to support a steam boiler. And basically, there are 4 systems that you as owners and operators, technicians, and repairmen need to be familiar with and need to pay close attention to. The first one is obviously the feed water system. Because in a steam boiler, there's one thing I can promise you. It is physically impossible to produce steam out of that steam boiler if there's not water in that boiler. If there's not sufficient water provided to that boiler, basically we will turn that boiler into a pile of molten metal. So the feed water system is extremely important. Now, the fuel system is one that typically stands out in many people's minds because now we're dealing with a combustible product. But this fuel system delivers the fuel to that boiler for the combustion and for the maximum heat transfer to occur. Now, we have a third system called the draft system. Now, the draft system is the way that we introduce the air into this boiler and provided for my primary combustion and to provide the secondary air to improve the efficiencies, but also to give the enough air and movement inside of that boiler in order for the gases of combustion to move through that boiler to maximize our heat transfer. And then the fourth system in a steam boiler is obviously the steam system. This incorporates all of your valving and piping, steam traps, your loads, which may be heat exchangers or other things in your process that actually use the steam. So those are the 4 primary systems that are required for a steam boiler system. Now, hot water boiler systems will also consist of 4 systems. Number 1, we have a makeup water system, and the big difference between steam and a hot water boiler is in a steam boiler we're continuously having to make up fresh water. So we have our pumps and we maintain a water level in the boiler. But in your hot water boiler systems, these boilers are flooded, and we circulate that hot water in this system to transfer heat out here in our building or in our process. Now, in a perfect world, a hot water system is a sealed system. So once we fill that boiler with water the first time, we don't have to worry about putting water again. Unfortunately, we don't live in that perfect world. So sometimes due to leaks or other issues, we do have to make up water in our system. So we have to incorporate some means to do that. The second item is the hot water piping for that system. And this is the piping that is distributed out through my facility that transports the hot water out here to my process and to my loads. Then, two items that are shared common between both steam and hot water is that we must have a fuel system to provide enough fuel to meet the designed output of the boiler, and we must have a draft system that will provide the air necessary for combustion and to help us maximize our heat transfer by moving our flue gases through our boiler. Now, Another thing that we do have to hit on real quickly is understanding of boilers. As I said, a lot of times these things have been forgotten. Now, over 100 years ago, in reality, statements made by the ASME was that there were more deaths and accidents and injuries caused by boiler accidents and explosions than we experience today in car accidents on the highway. Obviously, that was not something that was acceptable. So, the ASME was brought in to write the manufacturing codes for boilers, because prior to that, anyone can manufacture a boiler. There were no standards. Since then, because of these standards and good engineering practices and having the inspectors to be able to enforce these codes, the safety of a boiler has drastically improved, and the accident rates have dropped. Now, that does not mean that we don't still have boiler accidents. I mean, every single year there are boiler accidents that occur across the United States, and in destruction of property and equipment, injury to people. In some cases, there are still deaths, and it is projected that there are approximately 2,000 cases per year that are recorded and reported as a boiler accident. So even though things have drastically improved, it hasn't completely eradicated the potential of accidents occurring. Now, what prevents these accidents from occurring are going to be the owners and the operators and how you maintain your equipment. Now, that being said, we need to start talking about what are some of the responsibilities in order to make a boiler safe. And one of the things that I always stress in any and every class I teach related to boilers, it doesn't matter if it's the novice or it's the experienced operator that's been there for 20 years. The most important thing in any boiler is water. So, anytime anyone walks into a boiler room, whether you're an operator or you're going in to speak with somebody in that room, one of the first things that needs to be checked and verified is the water level, that there is a proper water level in that boiler to keep it from overheating and potentially having an accident. So one of the first responsibilities of an operator is to maintain that normal operating level, water level, which is often referred to as the NOWL. Now, since water is so important, one of the second items that we need to bring to the attention of any operator or person responsible for a boiler is if for some reason the water level has dropped and the heat transfer surface areas have not been adequately protected and they've overheated, one of the things that needs to be instilled into every person is that you never add cold water to a hot boiler. Okay? Now, you hear the term cold water to a hot boiler. You have to understand that hot and cold, those are relative terms. And, we may have a deaerator that is feeding my steam boiler, which is providing me water at 227 degrees, but the metal inside of my boiler may be over 700 degrees. So now that 227 degree water is actually seen as cold water to that hot boiler. Okay, so you need to have good processes in place to know when it's safe to add water and when it's not. Another thing that should be done by operators is that they need to be able to test the safety and relief valves regularly. And now, whenever we say regularly, this has always been a point of contention. If you take a look at the original information in the ASME codes, they'll tell you that they want you to test your safety relief valves on your steam boilers once a week, and that is a lift test. Now, anybody who has been in this business for any length of time knows that whenever you first walk into a powerhouse, one of the first things they tell you as a new operator or a new person on the shift is don't jack with those safety relief valves, because if you lift them, they're going to leak. Well, the problem of it is that we have to do regular testing of these valves. Now, if you have a boiler that is up to 400 psi, steam boiler in design, and is not superheated, they said they wanted to lift once a week. Well, we're not going to do that. So the ASME has given you a variance, and they said, okay, well, if you're not going to lift them once a week, you must lift them once a month, just a pop test, to verify the valves are functioning and then you must document it and maintain this documentation. If you have a steam boiler that is over 400 psi in design and are superheated, on those we cannot lift those safety relief valves on that drum, because at that point in time we will stop the flow of steam through our superheater, which will cause the superheater bundle to burn out. Now, see, these are standard guidelines that the ASME has put out in order to make sure that you're in compliance. Make sure to check with your local codes and with the state to find out what their requirement is for the testing of the safety relief valve, as well as what the frequency is. One thing that I can tell you is that annually the safety relief valves on a steam boiler are supposed to be recertified. Typically this means that you have to take them off the boiler for most of your applications, send them out to a lab, they'll test them, rebuild them, send them back. And in a lot of applications it's cheaper just to replace the valve than it is to go through that testing process. For your larger boilers where the spring mechanism is exposed, those boilers can actually have a recertification of that valve still in place, and that's where they'll come out and they'll recertify the spring tension of that valve. Now, another key thing for an operator, make sure that you follow the standard operating procedures, or the SOPs, and all your instructions that are both written and verbal from the chief engineer at your facility. Number 5, maintain your proper steam pressures and your water temperatures. That is critical from an operation standpoint. Now, another area that becomes problematic for people is the only way to know that my low water cutoffs or my low water safety devices are functioning. That means we have to test them on a routine basis. Now, most of your daily inspections, at least once a day, you're coming through and you're doing what is called a blowdown on that water column. Now, I need to make it clear, the purpose of the blowdown of that column is to test the safety device and to ensure that the boiler shuts off when it gets in a low water situation. I've had many people tell me, well, I always thought it was just to clean the bowl out. Well, that's a positive effect, but that's not the reason why we're doing it. Also, on these low water fuel cutoffs, we have our feed water pump controls, so whenever we're testing these, we're also being able to see if our feed water pump controls are functioning properly. Now, whenever we blow down our water column, we also need to blow down our low water cutoffs. We need to blow down our water column and our gauge sight glasses to make sure that they're clean, they're clear, and nothing is obstructing. And that so whenever we go to verify water level and we look at these water columns, they give us accurate readings. Also, any tricock. See, a tricock is technically at this point not necessarily required as long as you have a secondary means to verify water level manually. But if you only have a single sight glass, then tricocks aren't required. And so then you use these tricocks and you cycle these tricocks to make sure that they don't get stopped up or corroded or built up in there that'll prevent them from functioning properly. Always maintain your burner according to your manufacturer's recommendations. Maintain your proper fuel, oil temperatures, and all your gas pressures. Key thing, always record your fuel consumption regularly, because this is going to be a key indicator for you if you're having issues, if you've got leaks in the system, or you're starting to have heat transfer issues in the boiler. And then also, maintain your optimum feed water temperatures. We want those feed water temperatures as close to the temperature of the water in the boiler to improve our fuel consumption. The greater that temperature difference is, the more heat it takes just to heat water and not necessarily convert it over to steam for use in our process. Now, record your makeup water consumption regularly. Monitor and record your stack temperatures. Gentlemen, these stack temperatures are no different than you and I going to the doctor with a fever. If they take your temperature and you're running a fever, they know you're ill. Well, when I record these stack temperatures, basically this is going to tell me if my boiler is sick or if it's healthy. And when I start seeing stack temperatures beginning to elevate, that tells me that now the heat is going out the stack instead of being transferred in my boiler into the water in my process. So keeping good records there is extremely important. Key thing for all operators, maintain control of your boiler at all times. Okay? Observe everything about that boiler and all of its auxiliary equipment. And then critically maintain the boiler room log. record all your appropriate information that you're supposed to gather, but then also document any unusual conditions. This helps support you on your maintenance side of things. Now, when we start talking about the preventative maintenance side of it, there's a few things that we need to look at. Number one, for any of you that have boilers, there's two sections of the ASME code, and the ASME code, or ASME, stands for the American Society of Mechanical Engineers. All right, and in this boiler code, there are two sections. ASME Section 6 is for the operation, maintenance, and repair of low-pressure steam boilers and hot water boilers. And then in ASME Section 7 is for the operation, maintenance, and repair of power boilers or high-pressure boilers. These two codes provide the rules and the guidelines that you need in order to set up your program to take care of your boiler. I recommend everybody who is responsible for boilers to at least have these two documents available for reference and to constantly update your systems and update your program. Now, the boiler manufacturers, they use the information from ASME Section 6 and 7 to develop their preventative maintenance procedures for your particular boiler. Okay, sometimes I know it's hard to believe that everything that the manufacturer recommends for you to do on that piece of equipment is actually necessary, but I can promise you that we could add a lot more to it. It's basically the bare minimums. Okay. Now, whenever you use these manuals as the first step in creating your maintenance program, along with the information from the manufacturer, that'll help ensure that you're doing everything possible to ensure the safety of the people around it and the safety in the operation of the boiler, and to help you maximize the efficiencies of these boilers. Now, 10 steps to reliable boiler operation is, number one, know your equipment. There's been many times I've been to places that I'll ask them, well, tell me about your boiler. And the answer I get is, well, I don't know much about the boiler, but I know where it is. And, that's a good first step. But, if you're responsible for that piece of equipment or any piece of equipment, know everything you possibly can about that equipment so you know how to respond in both the good times and whenever there's an emergency. Regardless of the size of these boilers, every facility needs a standard operating procedure manual for their boiler room. And this should detail all the operation, maintenance procedures, as well as safety procedures that are necessary for the people who are responsible for it. I'm a very strong proponent of this. Your boiler log sheets, these are going to be your best method to ensure that your routine procedures are performed as they have been scheduled and things aren't being missed. Your written logs should be developed and used consistently by all of the people who are in the boiler room. Okay? Then whenever you do this, you'll establish set schedules for performing your hourly inspections, your daily, your weekly, your monthly, and your annual inspections and walkthroughs. Anything that is preventative or maintenance related needs to be recorded in your log sheets. And then to make sure that you provide good notes of what was found in the abnormality and what was done to correct it, so that in the future, whenever things happen again, people know they have a history to work with. Maintain accurate and complete records of service and repairs and any replacements on all your boiler room components. This includes your pumps, your motors, your belts, any steam traps, anything that you've had to change. Now, one of the things about it, as owners and operators of this equipment, obviously even on a boiler, some of the controls and devices become obsolete. At that point, it is your responsibility to find something that is to replace it and then update your information for the future to make sure that everyone knows that a change has had to be made. Monitor your water consumption, because this is going to give me a good indication if I'm having problems. This could also give me a good indication if I'm expecting potential water treatment issues or if I've got leaks. Monitoring that information is extremely important for you. Monitor your fuel consumption. We've spoken about that. The more fuel I'm using usually indicates I'm not having proper heat transfer and I'm potentially having issues. Ensure that your boiler room has adequate combustion air and ventilation. I will tell you this. A boiler room is supposed to be a relatively secure area, but whenever you open the door on that boiler room, you're not supposed to have to fight the door. If you are, what that is indicating is that there's somewhat of a vacuum or a lower pressure in that boiler room due to not having enough air and ventilation in that room for what the boiler needs, and so therefore it changes the pressure inside of that boiler room. Now, adverse effects to this is going to be incomplete combustion and unburned and unwasted fuel. Okay, so watch for any and all signs for negative pressure inside of your boiler room. Properly maintain your boiler room electrical systems. This is critical, gentlemen. I've been seeing way too many control panels inside of a boiler room that looked as if a bird had built a nest in there with all the wiring. I can promise you, when it came from the manufacturer, it wasn't that way. So, we need to take a little bit of pride to ensure that we can access our panels, that we access them safely, and that we keep the equipment clean and dry, because we don't want to have any nuisance electrical failures in our boiler system whatsoever. One good way that I use to tell how well a boiler room is or a boiler system is being taken care of is just by looking at the housekeeping of the boiler room, because it indicates two things to me. Number one, is there pride in this room, and are we doing everything necessary to make sure that it's safe and to take care of everybody that's in this space? or is it one of these areas that becomes a storage area for us and that we forget about? So, show pride in keeping that boiler room clean. It's not designed for storage of other products. It is an area that is supposed to be safe, secure, and in order to protect everybody around it. And always incorporate safety first. Okay. Use the OSHA lockout, tagout procedures, confined space entry, and always use your personal protective equipment. Boilers can be perfectly safe. However, they can also be extremely dangerous if we don't follow the proper safety protocol. And there are a lot of chemicals and things inside of our powerhouses and in our boiler rooms. Make sure that you familiarize yourself with the MSDS sheets or the material safety data sheets on the chemicals being used in there. Now, another thing that we need to do with our boilers is we need to have a baseline of what this system should be doing. And what the baseline does, it helps us establish a record of what the system's normal operating characteristics are, so when something begins to change, it is a trigger for us to start looking for the problem. Now, we start this baseline whenever the system is operating correctly. Okay? Now, whenever you collect data for your baselining, it will help the service people or maintenance personnel that you have become familiar with the system's operating characteristics, where the devices are, and the function of these devices. So baselining covers, it helps us with several things. Now, some things that we're looking for in baseline collection: what is the manufacturer of the equipment? Is it a steam system, a hot water system? Is it used for heat, or is it a process? Collect your nameplate information on the boiler. What's its model number, manufacturer number, heating surface, fuel used, maximum allowable working pressure, serial number, date of manufacture, its horsepower or pound per hour output of steam or BTUs per hour consumption, as well as our operating pressures. These are all critical things in order for people to refer back to when we start seeing issues with our boilers. Now, whenever we do temperature and pressure readings, we should take various readings throughout this system during normal operation, so we have something to compare back to whenever we were troubleshooting these boilers and these boiler problems. Also, gather information on your auxiliary equipment. What is it? Type and its purpose, manufacturer, model number, and where it's located in our system. Example of some of these items are your boiler feed pumps, if you have a deaerator, if you just have a feed water tank, if you have condensate receivers. Get that auxiliary information collected so you have something to go back to. Also, your controls. Make sure that all of your operating and safety controls are tested during the baselining process for proper operation. Piping systems, I always recommend that operators Either A, if you've got a process and instrumentation diagram that you have, get familiar with it. If you don't, sketch one up. Have something there so you know where all the pipe sizes are, what valves you have in place, and controls and other components. It's always very, very helpful to be familiar with what you have in your system. Now, your log sheets, these are going to be crucial for you for your boiler maintenance program. Now, there are some log sheets that are provided. There is a link that has been provided to you that you can download these log sheets. Otherwise, you can contact other boiler insurance companies and a lot of boiler manufacturers, and they'll provide you log sheets. But the information is the basic information obtained from ASME Section 6 and 7. Now, we do have these. You can request a PDF format of them from us, or you can download them on the link provided for you. This is an example of a heating boiler log sheet telling across the top what device that needs to be tested, such as relief valves, water columns, low water fuel, circulating pumps, or burner operation. It gives the month on the left-hand side. And at the bottom, it gives information of why the testing needs to be done and what the process and procedure is. This is important information for you to have to be able to trend and document the characteristics of this boiler. The next one is for a high-pressure power boiler or a high-pressure steam boiler. You can see there are quite a few more items across the top that we need to be testing on a routine, daily, and weekly basis. And instead of it being a year schedule on the left-hand side, it's on a weekly schedule, so we can have a little bit tighter control. Now, some other things that we need to be considering is, the easiest from a service standpoint, and as a contractor, the easiest word to sell is that one called efficiency. And unfortunately, a lot of times, whenever people hear that word, the first thing that comes to mind is dollar signs. And in some applications, we do actually, by improving efficiencies, we do actually save ourselves some monies. But sometimes we can give you higher efficiency numbers on a piece of paper, but we can wind up costing you more money in the long run. Now, one of the key areas that people concentrate on is the combustion efficiencies of our boilers, which it is very important because our fuels are not cheap. We want to be able to maximize heat transfer. Most of our boilers, we're burning some type of a fossil fuel, okay? Now, this could be natural gas, it could be oil, it could be coal, it could be wood chips. But we're burning some type of a fuel, and we're expecting that process to release that energy to maximize heat transfer. However, in boilers, there is always going to be heat losses. Some of it, heat losses, is just in the conversion of the chemical energy to thermal energy in the combustion process. So it's going to be important for us to be able to maximize our air-fuel ratios to reduce the potential of losing excess heat, but also to help us make sure that we're not having unburned fuel going up the stack, that we're maximizing our combustion process and heat transfer, and that we're doing it in a safe manner. Other losses that we have in our boilers is just going to be through our heat exchanger. In steam boilers in particular, we lose heat due to blowdown. We have feed water heat losses. We're going to have convection losses. Even though our boilers are insulated, we have heat that radiates off of that boiler that we lose just to the environment that's surrounding it. Okay? And then we're going to have stack losses, depending on how our combustion process is set up. If we don't have enough air, we have fuel going up the stack. If we have too much air, we lose heat by heating just to heat the air, but then we also, because the gases of combustion are moving so quickly through that boiler, they're going out the stack. They don't have enough time to transfer through the metal and into the water. When we're looking at the combustion efficiency and flue gas analysis, obviously what all of us would love to see is that magical thing called perfect or stoichiometric combustion. And that's to where we would have the perfect amount of fuel provided with the perfect amount of air and the perfect timing to where we had zero excess air, no unburned fuel, maximum heat transfer. out of our boilers. And, you know, the only place in which we can get this perfect or stoichiometric combustion is in a laboratory. And I think it's safe to say, or in my history, I have never seen the majority of your boilers sitting in a laboratory environment. So therefore, you know, since we're not in that lab, we're not going to be able to reach perfect combustion. But what we're want to be shooting for is complete combustion. We're always going to have some excess air. But we want to have a minimum amount of excess air to burn all of our fuel to where we have zero unburned fuel, and we don't produce carbon monoxide, because carbon monoxide is a product of incomplete combustion, and carbon monoxide can also be toxic or poisonous for people if it's generated in large concentrations. So we'd love to reach perfect, but ultimately what our goal is going to be complete combustion. Now, there's whenever we're looking at calculating combustion efficiencies, for years we used the old manual ORSATs. And but even with those, one of the things that one of the pieces of information we had to have in order to calculate combustion efficiency was to determine what our net stack temperature was. Now, to determine what that actual net stack temperature is, you take whatever the temperature is of your supply air and subtract it from your stack temperature, and then that will give you what your net stack temperature is, or your increase in temperature from incoming air to what's going out the stack. Most of your electronic combustion analyzers out here today, they're reading the concentrations of oxygen, carbon dioxide, as well as the stack temperature to help you determine what the efficiencies of your boiler are. This is an example of the old manual analyzers and that we used in the past. Now, I still got a few sets of these personally, but you know they've been pretty much replaced by the electronic analyzers today. The electronic analyzers are a lot easier to use. Now, with these electronic analyzers, this method is going to be faster and more accurate than by using your ORSAT analyzers, assuming that you keep your desiccant clean and you keep your cells replaced properly. These electronic analyzers, they can be both portable and mounted on your boiler systems. On your permanent ones that are mounted to your system, these are called CMS, for continuous emission monitors. And these electronic analyzers provide you with a readout of your flue gases by your percentages and parts per million, the appropriate temperature readings of the stack and your ambient air, and the percent of efficiency of the combustion at the time the sample was taken. Examples of some of these electronic analyzers are these. Now, obviously, there are some newer ones that are out there available to you. You can buy these little analyzers as cheap as $900 and as expensive as $50,000, $60,000. Depends on your application and what you're doing. Now, we are given some guidelines by the ASME and other organizations of what we'd expect our combustion efficiencies to be and what some of the characteristics would be. Now, you notice it says here combustion efficiency from our fuel oil. If I'm firing some type of fuel oil, my net stack temperature from 300 degrees to 600. Then on the left-hand side, we have our carbon dioxide, CO2%, which is going to be produced anytime you burn a fossil fuel. And then you have your O2, which is, you notice we're going to have excess oxygen because we're not in that laboratory environment. And if you take a look at what we're looking here, you know, the lower the O2 concentration and the lower the net stack temperature is, the better the efficiency is of our boiler. But we have to find that fine line in doing this. Now, these are numbers that are based off of calculations. This does not guarantee that every single boiler is going to operate under these conditions at any given time. So you have to find where your boiler operates its best. And we're also provided information about our natural gas and the combustion efficiencies of the natural gas. Some approximate settings for our burners. If we take a look at 3 different types of burners, if we have an atmospheric burner, has no blower, it's depending on the natural movement of air through it. You know, where it's very common for us to see stack temperatures running from 325 to 500 degrees, 7 to 9% excess oxygen, but always, you can see here, less than 100 parts per million carbon monoxide. The analyzers that I deal with, they usually trigger at about 40 parts per million that I start getting concerned. Because, again, carbon monoxide is unburned fuel. On my gas power burners, 275 to 500 degrees, and excess oxygen, 3 to 6%, with carbon monoxide levels below 100 parts per million. And then my oil burners, from 325 to 600, 4 to 7% excess oxygen, and less than 100 parts per million carbon monoxide. Now, obviously, we should not have smoke, but gas atmospheric burners and gas power burners, we don't expect it. Oil burners, sometimes it can show up, but our target is to have zero smoke. Now, the other concerns that owners and operators and maintenance personnel is to make sure that you meet whatever the emission requirements are in your area. Now, the Clean Air Act amendments of 1990 has been trying to prove what we're doing or what we're releasing into the environment. There's 11 titles covered in this act, but Title 1 is the one that's most important for us on the boiler side, and that's the Clean Air Act amendment. And what it's doing is Title 1 of the 1990 Clean Air Act amendments is covers the attainment for our national ambient air quality standards. Now, these standards take a look at basically 6 criteria or 6 components or pollutants that we're concerned about. Number 1 is ozone, carbon monoxide, nitrogen dioxide, which is the NOx that people hear about, our sulfur dioxide, which is the SOx when we're firing oil, particulate and particulate matter that may lead to stack, and any lead that may be released into the environment. Under Title 1, they set up monitoring stations to determine whether locations exceed any of the levels set for these 6 pollutants. If the area does not exceed these limits, it's designated as an attainment area. But if it does not meet these standards, it's listed as a non-attainment area. And then they'll actually do additional testing to classify this, to classify it further to the level of what pollutants are being put out here. And they have classifications ranging from marginal, the best of the worst things that you can have, or to the extreme, which is the worst of the worst case scenarios. You need to check with your local areas to determine whether you fall under these guidelines and if you're an attainment area or a non-attainment area and what you need to do on your part. Under Title 5 of this Clean Air Act, they set up to where they have what they call state implementation plans, or SIPs. Now, the SIP plans, or the state plans, they maximally gave each state the responsibility to develop their own strategies to reduce these pollutants. Each state plan has to be approved by the EPA. In addition to the SIP programs that are out there, the federal government has also instituted a national minimum standard for pollutant emissions. Now, with these new source performance standards, or NSPS, they differ depending on the fuel used and the size of the equipment. And the way they classify your boilers is based on the BTU an hour input. Your largest boilers are going to be greater than 250 million BTUs an hour input. Your medium-sized boilers are somewhere between 100 million to 250 million BTU an hour input. And your small boilers are going to be anywhere from 10 million to 100 million BTU an hour input. That last one is what they classify in this standard as small boilers. One more area that we need to look at to help you with your operation, maintenance, efficiency, and whatnot is going to be the water treatment. Guys, water is the most important thing in our boiler. However, that's the most important thing there, but it's potentially the worst thing we can possibly put in our boiler because water is aggressive. So we have to make sure that we take care of this water to where it doesn't destroy our equipment or our system. Now, there's a company called the American Boiler Manufacturers Association, ABMA, and they have done the studies and the analysis to find out what water treatment control limits are for most common water treatment programs. Okay. Now, even though these are their recommendations, your boiler may have some special requirements that may make you operate outside of these or be more aggressive. Okay. But these right here are the minimums that we need to do to take care of our boiler. Now, the ABMA, the Boiler Water Control Limits, it's based off of what is our operating pressures. Then, based on our operating pressures, it gives us a parts per million range that is safe for our boilers based on a given pressure. As, for example, from 0 to 50 psig, our boilers can safely operate above or anything below 2,500 parts per million total dissolved solids, or TDS. Alkalinity should be below 500 parts per million, and suspended solids are not even considered there because we're at lower pressures. But as our pressures increase, you will notice that now from 50 to 300 psi, 3,500 parts per million dissolved solids, 700 on alkalinity, which is our total, and no more than 15 parts per million in dissolved solids. As we increase in pressure above 50 to 300, you notice our dissolved solid levels begin to go down, our alkalinity levels go down, as well as what is acceptable for our suspended solids. This particular chart provides you information on what we call a saturated steam system. You start getting into superheated steam systems or pressures above 1,000 psi. There's a lot of variables that change. Anything above 1,000 psi, then we have to start taking into account silica, which is sand that gets in here that will actually plate out on the surfaces as glass. So we have to start addressing those. But these are just the guidelines that's provided for us out here by ABMA. Now, one of the things that we need to understand, particularly whenever we're installing new boilers and new equipment, that we need to make sure that we clean internally in these boilers and the piping, because these boilers and piping are layered in oil, and this oil will contaminate our system. If we do not get it out of our system prior to putting that system into service, we were going to have years of problems and costly expenses due to the contamination of this oil. Now, if we do not remove all this oil, some of the common things that we see in steam boilers is going to be priming and foaming. We can have carryover of water in our steam systems due to that because it changes the surface of the water. But in our hot water system, the oil will prevent our corrosion inhibitors from doing their job and protecting our metal surfaces. Also, the circulation of the oil inside of this system will actually build up and film on heat transfer surface areas and start interfering with our heat transfer inside of our system. So it's very important for us to make sure that we clean our boiler and piping on our new boilers. Now, whenever we clean hot water systems, typically what we'll do is we'll flood this system. We'll add a blend of some sodium hydroxide or trisodium phosphate in here, heat it up, circulate it through here, and then we will dump that system once that oil has been made miscible with that water to where we can drain it out. We could also use sodium carbonate to do the same job. However, this should be introduced at the rate recommended by the manufacturer, because it can be potentially harmful. Heated, circulated, and then removed from the system, and the system flushed. Now, on our steam boilers, the best way for us to maintain our water treatment in here to stop corrosion, erosion, oxygen pitting, acid effects, and whatnot, is by injecting our chemicals on a on-demand-based bioautomatic system. Whenever we add these chemicals, we add it to the makeup water and going to our boiler, and it's based on what the current water conditions are at the time. Now, whenever we get into hot water systems and heating systems, typically the most common way and best way is hand-feeding dosages to these systems. Since they are flooded and sealed, and in theory we should not be losing water or having to make up water, we only have to coordinate this once. But we're going to feed the chemicals necessary to help prevent scale and corrosion inside of our system. Whenever you select your water treatment vendors, I know there's a lot of them out there, but go out here and find somebody who's reputable. When your company types, look at national sales and service companies, regional or sales and service, or even some specialty chemical sales and service companies around close to you. Then you can consult the Association for Water Technologies, which is the AWT, and they will actually give you a list of what they consider qualified water treatment specialists that is in your area. Now, finding them is the easy part. Making sure that they do what is necessary for you, it becomes important. Okay? Now, these things, whenever you're selecting one, these things should come into play on your selection. What is their history and reputation? Do they have a good service department? What services do they offer to you? And what is the education and experience of the sales and service staff that will be actually maintaining your boiler and equipment? Because, believe it or not, I can do as much damage to a boiler with chemicals as I can by not adding chemicals at all. Now, you also need to make sure that your vendor is accountable. Make sure the vendor provides you record keeping of your system's operation, and make sure that they provide you with service reports that are complete and detailed after every visit of what they found, what they've done, and what they're projecting or suggesting to you. And then make sure that your vendor does a follow-up with a designated maintenance person or operator on each service call, that they don't just show up and disappear. And then make sure that whoever that designated person is responsible for signing off on the technician's report, so information doesn't get lost in the shuffle. Make sure that the reports contain all the necessary information and that they're legible and that they're explained to you. Make sure you have a good chain of command in dealing with the vendor, and whenever you're dealing with this vendor and with the building staff, make sure that everybody understands what this chain of command is. Make sure that the vendor knows, his technician or whoever is responsible for your equipment knows who to contact if there's an emergency situation, or if there's a request for maintenance to be performed by your staff that are made to him, that request, if things are going unanswered. Maintain your periodic contact with the vendor service manager or the owner, and make sure that you meet with them at least semi-annually to review your system's history, what we're planning, and where we're going with our system. Because we've got to add chemicals, but we want to minimize this chemical consumption because the chemicals are expensive for us. And make sure you discuss any changes that might make the system more efficient or economical for you to operate at any given time. They are a good source of information for you. Now, as far as final thoughts, boiler safety never ends. There's obviously we have just barely skimmed the surface on information on boilers here. There's the boiler's magic is in the details of the pieces and the parts. Okay, but as far as operators and owners and of the equipment and whatnot, and people responsible for them, I always stress to all of those around you that the boiler safety never ends at any given time. So, for some of you, if you have any additional questions or concerns or stories or anything like that, obviously, I love to hear the boiler stories for the most part. You can email me at the following email address that is here. So, that being said, I hope the information has been beneficial for you, and look forward to hearing from you and answering your questions. So I believe now it's time to do our question and answer session.
Thank you, Tim. And at this time, we will begin the question and answer session. To submit a question, click in the text box at the bottom of your screen, type in your question, and then hit the Send Question button below. Questions will be answered in the order they are received. And as a reminder to all participants, a link has been placed in the text chat area in the bottom portion of your screen. Navigate to this link to download today's slides and graph packet. Again, that link is in the text chat window in the bottom of your screen. We do have several questions in queue here. I'll begin with the first one. What if air handling units need to be reset every AM when cold and cleaned and the vacuum where it's located and the problem is still there? My partner told me to leave it alone, but I think I will replace it. What would fix that problem?
Okay. Do you have that question where you can put it up on the screen so I can see it, please?
Yeah, absolutely.
There were several parts to it there.
And Tim, if you just scroll over to the questions and answers button just to the right of the text chat window, and just select that and go down to the bottom of the list, and the question will be listed there. If you click on it.
Cold. Well, whenever having to reset that air handler every morning, whenever it's cold. Now, whenever you say reset it, are you having to reset an airflow switch or whatnot? A lot of times, on resets. Now, there's two things that's going to cause that thing to trip. If you have airflow issues, then you will have to reset the airflow switch on that air handler. In some instances, if you're having to reset every AM the boiler or whatnot whenever it's cold, then or a function or a portion of that air handler, it could be actually a flow issue of water in the air handler itself. Now, that question is kind of broad. Now, if you're having to reset your boiler every AM, then typically what that means, because the air density changes, and as the air density changes, as the temperature changes for your boiler, we can actually start getting too much excess oxygen or airflow through our boiler that will actually change either the size of our pilot or prevent the combustion process from even starting. Okay? So, that being said, depending on which thing you're having to reset, if it's the boiler, I'd have a combustion analysis done on your boiler and have them do it and then do an O2 correction, but depending on whenever they do your analysis. If it's hot outside, then they can lock it down. Things are good. If it's cold, then they need to make sure that they provide a 1 or 2% excess oxygen safety factor, because as the air heats up, we're going to provide less. Okay? If it's out at the air handler itself, you need to determine, is it what portion you're having to reset? Is it the water flow issue or is it an airflow issue? And I hope that answered your question, but that was kind of broad.
Thank you. And our next question is, I think this may have been in reference to a slide. He says, what has to be sent out to be tested?
Well, the only thing that has to be sent out to be tested on your boiler will be potentially the safety relief valves. Okay? And the guidelines for that is that annually the safety relief valves have to be recertified. Okay? And what that means, most of you will have a brass, Conkle or Combraco safety relief valve. The spring mechanism, you don't have access to it. So, since that is the case, those would have to be sent out to a laboratory, a testing laboratory, for them to recertify that valve. Now, that being said, to test that valve will oftentimes cost about twice what that valve is actually worth or what you can replace it for. So, in a lot of your smaller applications, say in boilers that are 600 horsepower and less that have the brass safety relief valves, my recommendation has always been just to set up a plan of replacing those safety relief valves annually instead of going through the process of recertification. It's just not cost effective. Other than that, everything else it can be done in-house. The ASME code is specific, and it says that you as an owner-operator can perform the routine maintenance on your boiler, as long as it is not a code repair. And a code repair is considered any time that you have to do strike an arc or put a flame to the pressure vessel portion of that boiler. So your safety relief valves are potentially the only thing that you will be sending out.
Thank you. And our next question is, without the addition of any chemicals, caustic or sodium triphosphate, the pH of the water in the boiler is around 12.0. We feed softener water, which is only pH 7.0. Would you please explain why?
Well, it depends. There's different types, of water treatment. You have just your standard phosphate plans, and those that you are having to do some things to coordinate pH, but you're not adding things for that coordination. So it sounds almost to me that you may be adding a polymer, and whenever you add these polymers, depending on the dosage, it can cause some unique situations to where it will drive the pH up. Now, on your particular boiler, what you're seeing there, if you're seeing that pH, if you're seeing that pH prior to going to the boiler, that's perfectly normal. And because we're going to run, or typically we want to maintain a pH on a steam boiler above 8.5. at any given time, because anything below a pH of 8.5, my boiler sees as acidic. So at 12.4, it's not ideal, but, I mean, it's something that's livable. But now we have to be careful that during normal operation that we're not continuing to see that pH drive, because once we get up, to 13, 14 on a pH, then it becomes just as corrosive as if we had pure acid inside of that boiler. So, and to answer your question directly, it sounds like maybe a polymer's being added, and that's what the cause of driving that pH would be.
Thank you. And our next question is ASME Section 1 followed for the design of heating boilers?
No. ASME Section 1 is for our power boilers, high-pressure steam boilers. ASME Section 4 is for the manufacture and design of low-pressure steam boilers and hot water boilers.
Okay. And our next question is it mandatory to follow the burner management system, BMS?
Well, ideally, I would say yes. But here's the problem. A lot of times, whenever the BMS systems are set up, if you're talking, say, from a control room, to where you're monitoring these boilers externally, initially when they were set up, they were set up for optimum efficiency of my system. However, things could have changed inside of this system. So, I mean, a lot of times it's very often, particularly on your larger boilers and larger systems, there are portions of it that you have to run in manual to help maintain it, okay, to maintain what it's providing out here to your system. Now, if you're talking about the flame safeguard, and some people refer to this as burner management system, or the controller that's on your boiler, then the sequence of operation for that controller that monitors the boiler and controls combustion, startup, and shutdown in sequence, that sequence has been predetermined that needs to be done for safety purposes. So if it's the device on the boiler for the monitoring the boiler, yes, we have to follow that. If it's external remote operation, not necessarily. You can operate portions in manual, and once you find out where your system operates the best, then they can reprogram your BMS system.
Okay, and our next question is, how often should water chemistry be checked?
Depends on your boiler. I mean, most companies, they have contracts set up with a vendor to where they'll come out once every 30 days, and then magically they show up, and then they disappear for the next 30 days. And in small applications on low-pressure steam boilers, a lot of times that's fine. Whenever you start getting into your larger boilers, larger steam boilers, the minimum that I would expect to see my water treatment guy out there would be at least once a week. And then I would request from them to train potentially some of my operators to do some sample testing just for comparison, that we would pull samples at various locations on my system on a daily basis and check the pH and, and my boiler and my condensate return. And as well as potentially looking at the alkalinity or what our TDS is. In that way we have something so when he comes in to kind of refer back to make sure that the information he's getting is really indicative of what our system is seeing the majority of the time. But, at least on large systems once a week, on low-pressure steam systems every 30 days, and on hot water heating systems, usually about every 6 months. Because if you're not making up water, that system is stable. And if you're starting to make up water, you need to make sure to notify your water treatment guy immediately, because the characteristics of the water are changing, and they can become harmful for your boiler.
Okay, Tim, if you could scroll down and select the last question on your list. You're probably better versed at some of these terms than I am, and if you could read aloud to the audience.
Here's one. It's, do you recommend opening a pressure relief valve for annual testing of the valve, or should you just leave it alone? And, gentlemen, by the requirement of the ASME, you are required to do what is called a pop test on these safety relief valves. And these are the ones I was talking about, at least monthly, and then to do to ensure that the valve is operating. Okay. Now, a pop test, we're not going to do a capacity test on our boiler. Your inspector has the option for you to make you do this. Not recommended, because you're making a gross assumption that the safety relief valve is actually going to function. Now, whenever you do a pop test, we're just making sure that the valve will unseat, open, relieve the steam, and when we release it, it will reseat. Okay? Now, the problem of it is a lot of safety relief valves that when they're pop tested, they're damaged because the procedure is not in place to do it properly. Okay? Number one, you need to know what the set point is on that safety relief valve. And you must make sure that you have at least 70% of the rated relief pressure of that valve on that valve, at the inlet of that valve. If you have anything less than that, you will potentially damage the stem, the spring, and the seat. Okay? So then if we have the 70%, then all we're doing is we're just lifting that handle off the seat to where it blows. We're not holding it open to blow a huge amount of steam out. We're just making sure that it will unseat, and then when we release it, that it reseats. Okay? I mean, it's important to make sure that happens. Because, let me explain why. Most people don't understand. They think that the nastiest, dirtiest water in the boiler is in the bottom of that boiler. Well, only maybe 10% of the contaminants fall to the bottom. The remaining contaminants that are in that boiler, the majority of them, are in the top 3 inches of that boiler. Now, if you think about where the safety relief valve is located in your boiler, it's in the top region of your boiler. Okay? So, that being said, it's exposed to the potential of these contaminants plating out on that disc and that surface and preventing that valve from opening. So that safety relief valve, it is a safety element. It's not a control element. And it is literally your last line of defense to prevent that boiler from overpressurizing. Okay? So it's critical to ensure that they work. I know we've been told, don't touch them, they'll leak. Well, guys, if we test a relief valve and we lift it and it doesn't reseat, fine. We'll come back and get the pressure back on it. We'll lift it a second time, because maybe some contaminant got in that seat and it's preventing it from seating properly. And we'll give it a chance to flush that. I'll lift it a second time. If I release it that second time and it doesn't reseat, I'll be nice and give it one more shot. And after that third time, if it doesn't reseat properly and doesn't function properly, guys, at that point we got to replace the valve, because the valve was bad already. Okay? I mean, this is the only device that's going to help you keep from having a pressure vessel failure to overpressurization. Okay? Which one? Okay. This whole question here?
Yes.
It says, one of the schools I was asked to check in the mechanical room, one of the glycol circulating pumps quit last year, and they never replaced it. They had 2 pumps installed, and they quit within a few months. I checked the manuals, pulled the pumps, and measured the impeller, and it was 7 inches, while the original was an 8.5. Would that cause the pump to burn out because of different size impellers? Pulled 2 pumps off, and pulled the second pump off, and it is an 8.5. Your impeller, just to answer that one, the impeller diameter on that, if you think about the characteristics of a pump, and what you have there is just a centrifugal circulating pump. And the impeller diameter, what it's going to do is it's going to change the performance characteristic of the pump itself on the amount of head or pressure that it can generate and the amount of flow that the pump will put out based on its pump performance curve. Now, by putting one in here that had a 7.5-inch impeller, would I necessarily expect that to be the root cause of that pump failure? Probably not. Matter of fact, if it had the same housing and we just reduced the pump impeller size, we would actually shift the pump performance of that particular pump, producing less head and less flow. So therefore, my horsepower requirements and current draw would be less on that pump with the 7-inch impeller than it would on that one with the 8.5. So I wouldn't necessarily say that the impeller size is the root cause of those failing. I'd look for some potential other issues. Now, if it's just a pump failure, we may have some things that are inhibiting the flow. If it's a motor failure, look for some environmental conditions that may be causing this. Sometimes what you will see is people install variable frequency drives on them, reduce the RPM on them, and they can't provide enough airflow to keep the motor cool, and so therefore you wind up destroying the insulation of the motor failure. Sometimes it's other environmental conditions, washdowns, things like that wind up knocking the pumps out. But I wouldn't look at it just strictly as an impeller issue.
Thanks for answering that, Tim. I'll move on to the next question here. What situation would cause superheated boiler tubes to glow red and deform? Is this a cause to shut down the boiler?
Most definitely to shut down the boiler. If you understand, the superheater tubes are a secondary heat exchanger that oftentimes is built integral into a convection section of a water tube boiler design. And, our steam comes off of the steam takeoff nozzle off the top, and then it's brought down and circulated through the superheater tubes to gain additional heat and to improve the quality of that steam, which basically means that we're drying it out. Okay, we're getting it drier before we put it out in our process, because maybe we're driving a turbine or there's something in our process that cannot handle that 1.5% to 2% moisture that's carried out into the system. So we got to clean it up. But what will cause those superheat boiler tubes to glow red and then start to deform is lack of flow when the boiler is operating. If you take a look at your normal startup procedures whenever you're lining up your valves, whenever you start that boiler up, you always have the vent lines or the drain lines on the superheater open to where we can make sure that we have, flow of my gases or my steam through the water side or the steam side of it. If you do not have that flow, there's no way for the heat to transfer. Now, the good news is with these superheater bundle tubes, they are a little bit thicker than your boiler tubes are. So there is a little bit of extra safety there. The downside of it is that extra thickness, even though it helps you on one aspect, it winds up potentially hurting you on another, because additional heat will be held in those tubes, and therefore they will overheat and deform. If they've glowed red and they've deformed, you've changed the chemical characteristics of the metal. And typically those superheater bundle tubes are an ASTM SA178 grade A ERW tubing that they use in these superheater bundles. So they're not the highest quality metal to start with. And once they've cherried and they've deformed, it is a point that probably we need to shut that boiler down, because it won't be long before those tubes rupture.
Thank you. Our next question is, what is considered a good electronic combustion analyzer?
Well, see, that's kind of a loaded question. And the reason why is there's a lot of different manufacturers out there that manufacture them. But it depends on what you're wanting to do. If you're wanting to just, monitor and maintain your boiler, Bacharach makes a little handheld unit that is very functional. It's lightweight. It'll measure your O2, your CO2, stack temp. It'll give you your efficiencies. It'll give you your carbon monoxide readings and those things. Relatively inexpensive. Some of your warehouse vendors. I mean, there's a few locations out there you can buy that little back rack for around $900. If you're getting into where you're needing to monitor your NOx or your SOx, or need capabilities for printing out for customers or whatnot, if you're a contractor, I use an Interac 5000. It's a satchel. It's in a stainless steel case and satchel that you take out here on the job site, and everything's right there. But obviously there's a huge price difference. Whenever the more add-ons you put on here, the more expensive it is. But just for routine combustion analysis, I'd tell you a little back rack.
Thank you. And our next question is, how important is an HP shift logbook compared to the hourly log sheets? What style of logbook should be purchased?
Well, to kind of clarify what he's saying there on HP for a high pressure boiler shift logbook. A lot of times on your hourly log sheets, I mean, you're going down and you're taking just your routine readings, your pressures, temperatures, set points, things like that. And a lot of times on those hourly little log sheets, you can get the normal operating information. But if you have issues or some of you see little nuances about the boiler change a little bit. A lot of times there's no place for you to really put that on your hourly logs. So whenever that high pressure shift logbook is critical to you, because now I can transfer my information as my averages, I guess you could say, for my hourly log sheets on a shift. But it also gives me a place to be able to go into more detail of problems that I've seen on my shift, or things that I've seen out of this boiler during its operation. So the shift logbook is important, because normally, to be honest with you, if I was sent out somewhere to work on somebody's boiler, one of the first things I'm going to do is ask them for their shift log, and I'm going to go back through several shifts to see if I can see something. And it's a quick answer for me, instead of having to go on these hourly logs. Okay, and as far as the type, what I tell people, just a ledger, not just a ledger book, is typically what I recommend to people. That way, that gives you plenty of room that you can put the date, and you can go into more detail that's there. And, usually these are hardbound, and at the end of the year, you can take that one out of service and you can bring another one in. They're inexpensive.
Thank you. And our next question is, how often should a manifold gas pressure test be done?
Well, that comes back to kind of jurisdictions. A lot of there are two codes that are also brought into the equation whenever it comes to routine or annual boiler maintenance. One of them is called CSD1, which stands for Controlled Safety Devices 1 of the ASME Boiler Code, and this is for boilers up to up to 12.5 million BTU an hour input. Okay, and then you have another code which is put out by the National Fire Protection Act, or the NFPA 85, in which that is the sister to the CSD1. CSD1 covers your smaller boilers. NFPA 85 covers your larger boilers. And with those two codes, there's annual inspections that you're supposed to be doing on your fuel trains and control elements and things like that. And part of that requirement for the testing of CSD1 and NFPA 85 is that annually you're supposed to be testing your gas valves, your manifold pressures, and those sorts of things. And that is a document that you do annually. It's documented and the record retained. Should something happen, that is you showing due diligence or a good faith effort to do everything possible to make that boiler safe.
Okay, and our next question is, let me see here. What is your opinion of aluminum cast sectional boilers in regards to industry and chemical makeup?
Of aluminum cast. cast section. Well, number one, and whenever they're saying aluminum, aluminum's not the greatest of heat transfer mediums, I'd say, for boiler applications. It doesn't work very well. Now, it may be an alloy of some type, but as far as chemical requirements and things like that, a lot of the standard chemicals that we use for just standard boiler water treatment, aluminum and some of your softer metals can actually be pitted and damaged by certain water treatment chemicals. I mean, as a whole, for the people that are out here, I mean, if you say you have a cast iron sectional, regardless of the type, and something happens and you have to replace it, you have to make sure that you get with the manufacturer or your vendor, and you have to tell them up front if you intend to use water treatment or you don't. Because if you don't tell them anything, then they're going to send the push nipples and seals for a boiler that's not going to have water treatment. And the minute you put water treatment in there, it'll destroy those push nipples and seals and it'll start to leak. It also voids the warranty. So, you need to make sure you let your vendor know right up front what you're dealing with. But, most of your softer metals don't handle very well the chemicals, a lot of your water treatment chemicals, very well.
Thank you. And our next question is, I was wondering whether any material is leaking out inside the boiler, which in turn raises the pH. In fact, we are adding polymer to bring down the pH. I think that may have been a response to an earlier question.
Okay. Well, and I answer that one. If he has a fire tube boiler, a Scotch Marine boiler, whenever you open the front and the rear doors around the tubes where they penetrate through the tube sheet, are you seeing if there's a white haze or a film that's there? A lot of times what that is due to bad circulation inside of the boiler, we will have areas to where my alkalinities and things will change right there where those tubes penetrate that tube sheet. And as the alkalinity levels increase, our pH increases drastically. And then we can even get into a point to where we can have an effect called caustic embrittlement. And it's to where the pH levels just get so high that it starts changing the physical characteristics of that tube sheet, makes that steel almost like glass. It becomes brittle. And a good way to check that is, you have them check your alkalinities. All right, and then if you do have the fire tube boiler and you open that door, and you'll see it'll look almost like a white to a yellowish milky granule that is built up around and on the face of that tube sheet where the tubes are coming through. So, and that would all be driven at that point, if you are adding that polymer to help you with that, that would be indicative that you're having some flow issues potentially up there on that front tube sheet or on the tube sheets themselves of our water.
Thank you. And our next question is there any way to safely check safety pop-off valves without standing on top of the boilers and pulling the handle with 105 pounds pressure?
Yes. The various boiler companies or vendors, they sell them, or you can make your own, is to make yourself a chain pull, which is nothing but attaching a rope or a chain mechanism that goes up through a pulley to where and then you can bring the handle down to the ground level to where you can actually lift that safety level by using a pulley system.
Thank you. And our next question is the certification or replacement of PRV requirement an ASME national code, or do some states differ? Does it include all pressure vessels, such as water heaters?
Well, water heaters is one of those weird ones. It kind of depends, because a water heater, its BTU hour input is below what is considered, even though it is a boiler, it is not considered a commercial boiler per se. I say 30, 50 gallon water heater. So therefore, then it's going to fall under its plumbing codes. Now, whenever, as far as the pressure reducing valve coming into it, the only thing that is addressed from an ASME standpoint is that based on if I have a low pressure hot water boiler or a high pressure boiler, based on its design, is that I must install a pressure reducing valve to make sure that I do not over pressurize the vessel or stress the vessel. That's the only thing. That's only addressed the ASME has put into it, and basically, I mean, they're not making you recertify your pressure reducing valve on them. And as long as they're functioning properly, they're okay. Now, some states, they are a little bit more stringent whenever it comes to some of your auxiliary devices coming into your boiler. So, you would, it is not just a national code that covers it. So you would have to check with your local state and jurisdiction, as well as potentially even your plumbing codes.
Thank you. And our final question in the last few moments of our call today, it may have already been answered, but the question is, what safety precautions need to be taken when doing the pop test? Is the boiler in operation?
Yes, the boiler is in operation because the boiler, the boiler's running to, because you got to have at least 70% of the rated pressure on the valve. And so the boiler is in operation. The precautions for that would be to make sure that you have that 70%, that you use proper PPE, which will be your, leather gloves, something to protect you from potential steam blowing out through some of the vent ports and things like that. And make sure that you're located to where whenever you lift that safety relief valve, that you're not going to be exposed to the steam that is escaping. And then also make sure that where the discharge piping goes out away from your boiler and out of your building and is vented outside, make sure that, if it's in an area where there's traffic or anything like that, that people know that you can't be in this area at this time. Because, obviously whenever we lift that, live steam's coming out, and people can be potentially exposed to that, and the temperatures of that steam will cause severe burns, very, very quickly. So, make sure that nobody's in that area. But make sure, wear your safety glasses, wear your clothing and gloves and other PPE to protect you from burns while you're doing it. And ideally, I know I've always hated lifting the valve right on top of the boiler myself, but there are some instances that, there's just not a better solution. If you can put the pulley mechanism on there, that's great. It gets you away from it. But other than that, just use common sense, be smart, and wear your PPE.
Thank you, Tim. There are no further questions or comments at this time. As a reminder to all participants today, a link has been placed in the text chat area in the bottom of your screen. Navigate to this link to download today's slides in the graph packet. And additionally, if your question was not answered during our time today, feel free to send your question to Tim's email address posted on the current slide. Again, feel free to send your unanswered questions to Tim's email. And it appears that we have no further questions or comments. I would now like to turn the call back over to you, Tim, for any concluding remarks.
Okay. Well, folks, first off, I want to thank you for attending our little webinar today. As I said earlier, I hope it has been beneficial for you. And as I told you at the beginning, I am passionate about this because it's getting difficult to find people with experience with boilers. And so a lot of times there's some bad habits that are put in place, and things that have been forgotten, and things that we just don't do. And it's not necessarily, I'm going to say, anybody's fault. It's just that we don't know. So, again, this was just touching the surfaces of things we need to do for our boiler. They are a maintenance-intensive piece of equipment. And, it's not difficult, but, we have to stay on top of it. I look forward to any questions any of you may have. As I said, I hope you've enjoyed the information, and hope to hear from you in the future. I want to thank you on behalf of myself and American Trainco, and hope you have a great day.
And thank you all for your attention. This concludes today's conference call. All participants may now disconnect.